Good morning. We're going to talk about graphing rational functions. Now, a rational function looks like, oh, I don't want to get into that yet. There we go. A graph of a rational function looks like this. It's going to have, it's like an inverse variation, right? So look at that. This would be your y equals, this is your k, and that is your x that you would have. So looking at graphs of these, let's go plug that into your calculator. So take a minute and plug it into your calculator. And then it's going to, we'll look at what the graph looks like right now, okay? Your graph should look like that on your screen. And if you look at where you're going to have an error sign, you should have an error wherever you're going to have a 0 in your denominator of your graph. Okay. So let's go and look at another one and go ahead and graph this one and let's see where the graph does not cross. So I'm going to guess that it's going to go, it's going to probably come down like this, and then it's probably going to come across like that. Okay, so there's a special word for these lines that they do not cross. Okay, it isn't crossing the line x equals 2, because when you put a 2 in the denominator, what are you going to get out? You're going to get a 0 again. So this special word is called an asymptote, and I'm going to show you how it's spelled. Okay, so an asymptote is basically a line where the graph doesn't cross. Okay, so you have graphs that look like, you have graphs that look like this, like we've been talking about. The very first one we did, it didn't cross this line right here. It didn't cross this line, and it didn't cross this line. So when the asymptote is going up and down, it's called a vertical asymptote. And when the line is going across, it's called, obviously, a horizontal asymptote. Okay, so let's do the same equation again, but we're going to subtract 5 here and see what causes a horizontal asymptote, okay? So the very first asymptote we had here was where x equals 2, obviously. This -5 is going to make the entire graph drop down 5 places, and so it's going to have a horizontal asymptote at -5, at y equals -5. So this is another kind of translation. So this is going to make it go to the right 2 places, and this is going to make it go down 5. All right, so with your graphing calculator, I want you to find the asymptote of this function. So take a minute to go ahead and graph that. Okay, so I'm getting something that's going to go, it looks like I'm going to have a vertical asymptote at 3. So I'm going to draw the asymptote first. And then my y-intercept looks like it's at 1. So I'm going to make sure that my y-intercept is crossing in the right spot. And then all you're going to do is draw a little curve to kind of indicate how it's looking. Okay? Now, if you're not getting the same graph that I'm getting, make sure that you are putting parentheses around your entire denominator. And it's really not a bad idea to put parentheses around your entire numerator. If you are using one of the newer calculators, I think you can do alpha y equals, and it will turn it into a fraction automatically. But if you're not getting that, make sure that you are using parentheses. Okay, so what I want you to go ahead and look at this. It's already graphed for you. You can check to make sure if your graph looks like mine. Make sure that you are using parentheses around the entire numerator and the entire denominator. Now look what it did. It did make an asymptote go here at 2, right? Because that's going to make it become 0 if we put a 2 minus 2 in there. So you can't have anything at 2. But it also raised the graph up to 3 spaces up. So you have a vertical asymptote at x equals 2, but you also have a horizontal asymptote at y equals 3. All right, so right now I can tell you about why that happens. I don't know if you need to know this or not, but it's because 3x divided by x is 3. That's why it makes it move up. So that's a little thing you'll know when you get into math analysis. But right now I just want you to be able to look at it and see that you have an asymptote there. Okay, so here again is one more definition of a vertical asymptote is any point or line. It's actually not a point. An asymptote is actually a line. A point that's going to make it happen is called a hole. So any line that will make the function undefined. So today in your notes, I want you to write that down. If you write nothing else down, write about what a vertical asymptote is. I want you to graph this function and then sketch a graph of the function, all right, on your paper. And that is all you're going to do today for your assignment. And tomorrow we're going to talk about much more exciting stuff like holes in a graph. And we're going to also talk about some other things. All right, so today that is your only assignment. Go ahead and copy down this definition and then graph this function and talk about what it looks like. All right, have a great day.